Okay, so PASS doesn't only offer this conference you are attending, it also offers SQL Saturdays, virtual groups, so be sure to check out the PASS website for all the offering from PASS. And also, at the end of the session, I kindly ask you to evaluate what you have seen, say if you liked it and why. This will help improve your experience for the years to come. And also, you have the possibility to win some nice prizes, so please do that. A few words about me. My name is Gianluca Sartori. I'm an independent SQL Server consultant. I've been working with SQL Server since version 7, so a long time. At the moment, I'm working as a DBA at a famous Formula One team who just didn't win the World Championship. And you can find my blog at spaghettidba.com, and if you want to follow me on Twitter, my handle is @spaghettidba. Okay, so the agenda for today. We will first have an overview of monitoring, and then we will see how extended events fit into the monitoring panorama. We will then go to the core of the presentation, which is how to stream extended events. And then we will try to see some possible applications of this technology. And then we will present two projects, two open source projects, Extended T-SQL Collector and ICSI Smart Target. Good, so monitoring. How many DBAs do we have here? Okay, this is not a surprise. Developers? One or two, perfect. The others are here for the coffee. Seattle coffee is great. Okay, so we have lots of DBAs here, and you are probably monitoring your instances. And you do that because you want to be able to answer questions. Questions along the lines of, what happened tonight when my ETL job was running at 3:40 and nobody was in front of the computer, and something happened and it started to go slower and slower and slower. In order to answer that kind of questions, you need to have some monitoring in place. Or maybe you want to tune performance, so the questions you have to face are like, which queries consume more resources, so you can go find them and tune them to have a better system. Or maybe you want to do some capacity planning, and you need to know how fast your databases are growing before you run out of disk space. And the only way to do that is to have some monitoring in place. Or maybe you want to know whether your system is behaving normally. And to know that, you have to capture what is normal, so your baseline, with some kind of monitoring. And only by doing that, you are able to tell whether things are going good or bad. And there's also another reason why you may want to have some monitoring in place, so that you are alerted when things are wrong. So when something wrong happens, you want to receive an email or some kind of alert. Great, so how should you do that? The easiest way is to go to one of the big names, like Sentry, Redgate, or SolarWinds, and buy one of their commercial products. They have fantastic solutions for this. They cover all possible kind of monitoring you need. The only downside to that is that they are a bit on the expensive side. So especially if you have many instances to monitor, that may not be the solution for you. The alternative could be to use some open source or free tools. Yes, it's cheap, but most of the time this is incomplete or unreliable. What usually happens is that some developer has to do some monitoring, creates a solution for that, for his specific needs, then uploads the project to GitHub or Codeplex or some place like this, and never touches the code again. And this is not what you call enterprise-grade monitoring. So the alternative could be to code your own, but this is a really painful road to go down. You will quickly discover that going to buy some of the commercial products is much cheaper because your time has a value. So another possibility is to stop trying to solve every possible monitoring need and focus on what is your current problem and try to solve exactly that by using the built-in tools in SQL Server. So what you have in this area, you have SQL trace, event notification alerts, extended events, and the data collector. So many tools in your tool belt for doing this. There are two possible approaches for monitoring. The first one is polling. So you go and query some information from information sources at regular intervals, and you store this information somewhere for later analysis. In this area, what you may want to pull information from is, for instance, performance counters. So you have counters specific for SQL Server, like page life expectancy, or counters from the operating system that tell you how is resource consumption, so things that have to do with the CPU, the disk, and memory, and so on. And other things you could pull information from, DMOs, so dynamic management objects. In this area, you have lots of DMVs and DMFs. You can go and query at regular intervals and store information somewhere. But this is not what we want to discuss in this session, because what we are more interested in is the other approach. So things happen inside SQL Server, and you have something waiting for these events to be captured. And before SQL Server 2012 arrived, the only way to do that was by using SQL trace. Everybody knows SQL trace, either server-side trace or by using Profiler. Everybody knows this because it's been in the product since as far as I can remember. Okay, so then SQL Server 2012 arrived, and we had extended events. Actually, extended events were in the product since 2008, but it was introduced as a way to introduce auditing in SQL Server, and it was not a complete replacement for SQL Trace until version 2012. Why even do we even need a replacement for SQL Trace? Because SQL Trace works great, but it also happens to have a non-negligible performance impact on the server. So we needed something more lightweight and also something that was able to capture events from more deep inside SQL OS. So we had extended events. So let's go through the core concepts of extended events. If you're sitting in a session entitled Responding to Extended Events, chances are that you already know a thing or two about extended events, but we will try to shed a different light on these concepts. First of all, what we encounter is the event itself. It is something that is fired by SQL OS when a point in code is reached. What does it mean? So imagine you have the source code of SQL Server in front of you. SQL Server is written mostly in the C language. So imagine you have the code in front of you. You're reading the code for SQL Server, and you probably have functions for starting some of the activities of SQL Server. So imagine, for instance, that you have a function for starting a checkpoint. So there's going to be a function called checkpoint. And some of these points in the code are interesting because they signal you that SQL Server is performing some action. So what you will have inside these functions is going to be a call like raise event. And that event will tell that we are inside that specific function. We will also have information inside the event to describe the state of the system in that particular moment. And this information, this payload we add to the event, is what we call the fields of the extended event. We could also decide to add more information to the event by using actions. Actions are additional sources for information, which is not available in the point in the code when we raise the event. So we need to run some additional functions to extract more information, and this is what the actions are. Then we have the session. The session is what defines what we capture and how we capture. So the sum of events, fields, and actions is the session, so what actually captures the event. Then we have the target. The target is what actually consumes the event, so does something in response to the events. We have different types of targets, some to store events in memory, some to count events. So they do different things, and depending on what we are trying to achieve, we will use different targets. We could also decide to add multiple targets to a session, or we could decide to add no target at all, so having a session running, but no target pulling events from the session. Great, so let's have a look at the types of targets we have in SQL Server. The first two are the most popular ones, the ones you probably use every day. First of all, we have the ring buffer target, which is a target which stores events in memory. You have events flowing to this queue in memory. New events are added at the beginning of the queue, and they push out all the events at the end of the queue. This is useful for storing some information about the events temporarily in memory and then discard these events without persisting them. Then we have the event file, which is similar to what we had with SQL Trace. So events arrive in the target, and they are saved to a file very similar to a trace. This is good when you have to analyze the data you are collecting afterwards. Then we have specialized targets for doing different things. Example, we have the event pairing target, which is useful for dealing with events that usually come in pairs. Think of lock acquired, lock released, and things like that. Then we have the event tracing from Windows, which is a type of target for associating and correlating SQL Server events with Windows events. Then we have two targets to count events. The first one, the simplest one, is the event counter target that simply counts events. So every time an event arrives into the target, we increment the counter. And we also have the histogram target, which still counts events, but it groups events on one of the fields or actions in the event before counting. So it could be grouped by database ID, for instance, or username, things like that. Okay, so this is the targets we have. Are we missing something? As DBAs, do we need to have anything else in this regard? Yeah, maybe. There's no target for doing actions in response to the events. There's no alerting target. There was initially a request on Connect to add a service broker target for this, but it was closed as one fix, even if I heard rumors that it may have been implemented in SQL Server 2017. I heard of it today for the first time, but I will have to check. So why service broker? Because with SQL Trace, we had event notifications for this. And event notifications are nothing less but a SQL trace with a service broker queue on top, and every time an event is recorded in the trace, it is also processed in the service broker queue. So they asked for something similar for extended events, but it was closed as one fix. So possible solutions. We could post-process the target. Imagine you have a file target with all the events, and you could post-process the target to see whether you got one of the events you were interested in for alerting. But this is not usually fast enough. If you want an alert, it's because you want it when the event is raised, not 10 minutes later or 1 hour later. So you don't have the time to wait for the session to be stopped or the file to roll over. Another possibility is to poll the target for changes, which is a bit ugly and hacky. I wouldn't do that if I had the chance. So you could also decide to use something else. We are not forced to use extended events. We could use SQL agent alerts or use event notification, because SQL Trace and Service Broker are both there. They're not going away from the product anytime soon. But is there maybe a hidden target type? I bet you have used the Watch Live Data window at least once. So in Management Studio, you have this window that is able to display events as soon as they occur. So have you ever wondered how it works behind the scenes? If you have the Watch Live Data window open in your SSMS and you run this query, select star from sysdmxc session targets, what you will receive is one row for each of the active targets on the active sessions in your instance. And while the Watch Live Data window is open, you will see something like this. In the target name column, you will see event stream, and in the target data column, you will see live stream target blah, blah, blah. So something that looks very promising. In fact, this is what you see when the streaming API is attached to one of the sessions in your instance. And the streaming API is exactly the response to this need. So this is the hidden target type that helps us with dealing with events as soon as they occur. Okay, so what I will do is I will now show you how to use the streaming API to create a clone of the Watch Live Data window by using the API objects in .NET. DBAs, I will open a Visual Studio, but don't worry, nobody's going to get hurt. It's going to be very simple code, so don't worry. Let's go to this virtual machine. Here we have a virtual machine with two instances of SQL Server. We have one instance of SQL Server 2014 and one of SQL Server 2016. Okay, so first of all, we need to set up something. We need to have a session, first of all. We will create this session, and this will capture RPC completed events, and also it will capture SQL batch completed events, so execution-related events. Then we will need to have a database. This database we will use for a synthetic workload that we will inspect with the streaming API. First of all, we need a database. So this is the database we are creating. It can be called ReplayDB. And it will contain one single table, test numbers. It will have a single column, an identity column. And so we will have the next value for the identity every time we insert a new row inside this table. So extremely simple. Okay, so we can go and create all of this. Great. Next, what do we need? We need a workload. We will be inspecting a workload. So this is a workload we will work with. This is going to insert a single row inside the test numbers table, so the next value for the identity. And then we will wait for 1 second, so the simplest workload ever. Great, so we can go ahead and run this. So we have one row inserted, 1 second wait, and then the next row inserted. And now we need to inspect this by streaming this execution-related events in a clone of the Watch Live Data window. So let's go ahead and do it. As I said, we will open Visual Studio. Okay, and I can start this project. Okay, so let's go inside the code and see what we have here. So this is the core object of the streaming API. It is called queryable X event data. And this is the object we will use every time we want to deal with extended events. We want to connect to an extended events session. We need to instantiate this object, and the parameters it needs are, first of all, a connection string, so where to connect to, a name for the session to monitor, so the session to attach to, and then two constants to describe the way the connection is going to be made. So the first parameter is event stream. The other possibility is event file. So we have two possible sources for this, a live session to stream or a file on disk to open to see the events stored in the file. Then we have do not cache. This tells this object to not cache the events in a file. This is one of the possibilities we have for this object. Then we have this for each loop. So basically, we are iterating through all the events captured by this event stream object. Sorry. So for each published event in the stream, we do something. And that something is we add a row in the top panel as we have in the Watch Live Data window. And that row will contain the name of the event and the time when it was captured, exactly as we have in the original Watch Live Data window. So just in case you don't remember how it is, I will show you the original window. I can go here and say Watch Live Data on the session we have created, and as you will see here, we have events that appear, so we have the name of the event, the timestamp, and then on the bottom panel, we have fields and actions with a name and value. So we want to do the same thing in a clone. Okay, so going back to Visual Studio. What do we have? So we need to let this go. We're at a breakpoint, so we just need to have this for each loop run and see if we have events showing up in the top panel. Yes, we have them. Here they are. So as in the original Watch Live Data window, we have the name of the event, so SQL batch completed, and the timestamp. Very simple. Okay, so if I click on one of these rows, I want to display fields and actions in the bottom panel. So I click, and what I have is this. For each published event field in event.fields, do something. Okay, so I have a collection for the fields, and I can extract the name and the value and add it as a row in the bottom panel. I can do exactly the same thing with the actions because I have an event.actions, an actions collection, and I can extract name and value and add this to the bottom panel. So it's really simple to use. Let's make this run, and what I have is bottom panel. So I have the field name, CPU time, the value is 0, and so on. I have all my name and value pairs. Good, so it was really easy, right? I can stop this, and let's go back to the slides. Okay, let's think for a moment of what we have just done. We had events showing up in a queue so we could process these events. We didn't have to shred XML. If you look for all the examples online for extended events, you always have to, at some point, use your Ninja XML shredding abilities, which I don't have. Who likes shredding XML? Yeah, nobody. Okay, so in this case, we just had to go through the properties of an object. We had a collection for fields and a collection for actions, and it was really, really easy to deal with. So possible applications of this streaming API. We could be doing multiple different things with this API. Well, we could watch events as they occur, but you already have the watch live data window for that. And also, I hope you have more interesting things to do in your day-to-day work. So you could set up something to respond to some interesting events as soon as they occur. Response, which could be sending an alert, example, an email when a particular event is raised. Obviously, it doesn't make sense for all kinds of events. Think of lock-acquired events. Don't send an email anytime one of those is found, unless you want to kill your Exchange server. Other things you could be doing, you could save some events, some interesting events, to a database table. We don't have a target that writes to a database table. You can do that with a streaming API. Also, you could use this same API, as I said, to open an existing file on disk and read the events inside without having to shred the XML. Okay, so let's try to do something particular. This is, yes, we have a question. The question is it possible to do with PowerShell? Yes, we will see that in a minute. Okay, so the streaming API could be useful for solving some of your day-to-day problems. In this case, we will replay a workload. So you could be thinking, why do we even need to replay a workload? We already have tools for that. Yes, we have, for instance, RML utilities. You have Profiler. You have the distributed replay feature in SQL Server for performing a replay. Yes, but all these tools have only one downside. You first have to capture a big trace file and prepare that trace file. And it could be time-consuming. It could fail during the pre-process phase, and it could also use lots of disk space on the server, which is a premium resource. So a different approach to replay could be to listen on the session for execution-related events, and as soon as we capture one of those events, we can replay the same query to a target instance of SQL Server. So let's try and do this with the streaming API. Let's go back to the virtual machine. I will close this project. We can close all of these. So we will be replaying this simple workload from the 2014 instance to the 2016 instance we have on this machine. Okay, so I will show you that we have the database here. We have the ReplayDB database on SQL 2014. And we have the same database here, the ReplayDB, with its numbers table inside. What I want to do is hook to the session on 2014, capture the events, and replay the workload on 2016. So let's go and rerun the setup. So I clear the tables. And then I can open a Visual Studio project to do exactly this. So what we will do, in this case, we will again use the queryable XEvent data object. We will pass a connection string, the name of the session, the two constants, and for each event in the stream, we will replay single event. So let's go to the function replay single event and see what it does. Okay, so we receive an event as a parameter. What we have to do is extract the command text. Command text for RPC completed events is the field statement. And for SQL batch completed events, the command text is the batch text field. So we extract that, and the only thing we have to do now is execute this text against the target database. So we go here, and as you can see, we can set up a connection to the target 2016 instance. We pass the command text to this command object, and then we execute the query against the target instance. So this is really simple. Let's see if it works as expected. So in order to do that, we need to go back here and start the workload. We will query the two tables, so the one on SQL, we need to switch this to SQL CMD mode, so we can connect to both instances. And as you can see, they're both empty, so no rows on 2014, no rows on 2016. Okay, so let's expand this. And rerun, still empty. Let's start the project, so this application, and the workload. So now it should be replaying the events. One row inserted, one row inserted. If we go here and query this, you can see we have some numbers flowing in. See, we have 12 here, we have 6 on the target, so the source has numbers going up, and the target has numbers going up as well. So this is working, the replay is working. If I keep doing this, you will see the target instance is a bit lagging behind, but at some point it will get there. Let's try to stop the workload and see whether all the numbers will be replayed to the target instance. 38, 37, 38. Okay, we have been lucky. We will discuss this later. Yes, we have a question. Yes, in that case, the code will have to be more complicated. I have a working example more complicated, but I didn't want to complicate this sample for this session. We can take this offline if you're interested. Excellent. So, okay, in this case, we had all events flowing from the first instance to the second instance, and we went to the same number, so 38 and 38. We will discuss this later. This is not guaranteed. Okay, let's stop this. Okay, so the question is, does it use a ring buffer to read the events from? No, it doesn't read a ring buffer target. The buffer is on the client. We will discuss this in a minute. Okay, so let's go back to our slides. Okay, what we have done is really nice. It's one of the many possible applications of streaming events with the streaming API. It's really nice, but it's not available in the T-SQL realm. So does this mean that DBAs need to learn C# to use it? Well, learning C# is obviously a good idea, but it's not required because the streaming API, as I had a question some minutes ago, is also available in PowerShell. So PowerShell is definitely more DBA-friendly than C#. And you can achieve exactly the same things. You could do that with a SQL agent job step with PowerShell, or you could have a PowerShell script running in the background, capturing all the events you're interested in. So what we will do now is we will have an example of capturing some logon events using the PowerShell API. What we will do here is we will try to address another a possible real-world problem using the streaming API. So imagine you have an instance you inherit from somebody that doesn't work for the company anymore, and you have many databases, you have many logins defined on the server, and you would like to restrict the logins to the minimum possible number of logins. So you only want to keep those that are active, and you want to disable those that are not active. So how can you do that? You would have to monitor your instance for a reasonable amount of time, maybe a month or two, and see whether some logins actually do log into the server at some point or not. So if you capture all the individual login events and save them to the SQL Server log or a trace file or an extended events file, you will quickly discover that you get quite a lot of login events in a day. So these files will get huge in a very short amount of time. And also, you are not really interested in all the single events. Everything you want to know is whether the login is active or not. So you're interested in when it logged in the last time, and maybe in counting how many times it logged in. So an aggregation of all the events. Okay, so let's try to do this by using the streaming API and PowerShell. So we will go back again to this environment. And this time, we will use Visual Studio Code to see what we will set up for this. Okay, so first of all, we need a session to capture the events. The events we're interested in are of the type SQL Server.logging. Okay, we will capture the database name, then the client application name, and the client host name and server principal name, so the name of the login. Then we will need a couple of tables for this. The first table is going to be a staging table. We will write the individual logon events to this staging table, where we have the date of the event, login name, host name, program name, and database name. So we will have one row for each event in the staging table. Then we have the destination table that will contain the aggregated information. So we have login name, host name, NT username, NT domain name, application name, database name, and then 3 columns that we use for aggregating this information. So first seen, the date the login was first seen, last seen, again a date, and a column for counting the logon events. So what we will need then is a store procedure to consolidate the data from the staging table to the target table. So what we have here is basically the store procedure that merges the data into the target table. Then we will use a job, a SQL agent job, and this is the code to create the job. I want to draw your attention to this, which is the action in the job step. So execute this script, collect audit login.ps1. Let's go and have a look at the code of the PowerShell script invoked by the job. Okay, so no surprises. We will, again, use the streaming API. But before we can use it, we need to add a couple of types, a couple of assemblies. And if you are using SQL Server 2012, you will need to add this xevent.linQ.dll. And if you're using SQL 2014 and above, you will have to add 2 DLLs, so xccore DLL and xevent.linq.dll. Obviously, you will have to take them from the correct version, so the path for your version. Oh, And again, we will have here a data table to store the individual events in memory. We will use this as a cache. We add some columns to the data table, so event date, original login, host name, program name, database name. Then we just need to stream the events, and again, we use the same object we used in C#. So queryable xEvent data, this is it, and we still pass the parameters, the arguments to initialize it. So the connection string, the name of the session, and the two constants. Again, we need to loop through all the events. So we have events, we pipe this to a for each loop, and inside the loop, we process the events. So what we do is we take data from the fields, so in this case, the field database name, the field server principal name, and the action client app name, action client host name, and we add a row to the data table. We insert a row in the data table, and every 10 seconds, so every 10 seconds, we dump this information to the staging table. And we do that by using a SQL bulk copy object. So we create this object, we write this queue, so the data table, to the target table in SQL Server, so the staging table, audit logging underscore staging. And then something will take care of moving the rows to the target table. Okay, so let's go ahead and see if this works. We can run the setup. So we create all the tables, the sessions, and everything we need for this. And then we need to query the tables. We have the staging table, which is empty, the target table, which is empty too. So let's move this. We just need to go and see whether we have the jobs. So let's see here. We have a collect audit logging job and a consolidate audit logging job. This one has a step that invokes the PowerShell script. So we just need to start this job. Okay, it's already running, so no need to start it. Perfect. Yes, the question is, the job will run continually. Exactly. It will never finish. It will always be running in the background. Okay, if I refresh the tables, what would I have here? I have in the staging table, I have the individual events. So one event for each logon event I captured. Then, in the target table, I have the information that is summarized. So I have one row for each combination of login name, host name, NT username, NT domain name, application name, and database name. And then I have the three columns I'm interested in. So first seen, last seen, and logon count. And if I keep refreshing this, I should see the numbers going up. Okay, as you can see, this just went to 7. If I run a workload in the background, I will capture even more events. Okay. So as you have seen, this is also very easy to do in PowerShell. Okay, so what we have just done, we have saved events to a database table. We have captured some performance-related information, and we have saved this information to a target table in a SQL Server database. This is familiar, right? There are some components in SQL Server that do exactly this. And the component is called the data collector. So in order to use the data collector with extended events, we would need to have something that is able to connect to an extended event session, extract the information from the session, and save it to one of the tables in the data collector database. This is called a collector type, and there is no built-in collector type for doing this. So I created Extended T-SQL Collector. Extended T-SQL Collector is a project, an open source project that you can find on GitHub, and it offers some collector types, 2 new collector types for dealing with this. The first one is for dealing with lob columns. I don't know whether you know this or not, but if you try to use the built-in T-SQL collector type to create custom collection sets in the data collector, you cannot capture lob columns. If you try to do that, the data collector will fail. So I built a collector type for dealing with these kind of situations. But I also created the extended XC-reader collector type, which is, as we were saying, a collector type which is able to connect to an extended event session, stream the events, and save them inside the data collector database. Also offers the ability to create some alerts. So when some interesting events are captured, you will receive an alert using database mail. Also, Extended T-SQL Collector offers you the ability to use a GUI to interact with data collector, which is one of the reasons why the data collector never really took off. It was without a GUI for creating complex collection sets. Okay, so if you want to try this, you can find it on GitHub. If you want to contribute, it's open source, so you can do so. What we will see now is how to use Extended T-SQL Collector to collect blocking and deadlocking events and receive an alert when any of those is fired. So let's see how this works. Okay, so we have here the GUI for Extended T-SQL Collector. This is it. If we run this, we see that we have here the list of the collector types. So these are the built-in collector types. And these are the 2 collector types included in this project. Then we have the built-in collection sets. So disk usage, query statistics, server activity, and so on. And this is a custom collection set to capture blocking and deadlocking. Okay, so what we have here, if we click the deadlocks collection set, we see that we have a collector type of the type Extended XC-reader collector type. And the parameters for this are, first of all, information about the session. So the name of the session to connect to, and it's called deadlocks. Then we need to have the definition of the session. So if the session is not running, it will be created by Extended T-SQL Collector. So it needs to have the definition for it. We need to have a name for the table where the information will be stored in the management data warehouse, so the database of the data collector. And we could also add a filter for the events. Also, we have the ability to have some alerts fired when these events are captured. So the alerts are based on this information. We need a sender, which is the name of a database mail profile, a target recipient, so the DBA, subject, importance, and column list. So here we can specify the columns, so the fields and actions we extract from the event, and we want to incorporate in the body of the email message we receive. Okay, so let's try and see whether this works or not. can go here and have a look at what we have in this instance. So under management, data collection, we have this blocking and deadlocking collection set running. So we just need to have some deadlocks now. SharePoint could be handy now to generate some deadlocks, but we don't have SharePoint on this laptop, so I will run a script. Okay, so let's generate some deadlocks. And what we expect to have is some email. So I have an email client here waiting for new email. So let's generate some deadlocks. We will use this script. Basically uses RML utilities to run the same statement in parallel multiple times, and at some point it will block and deadlock. Okay, so we have some messages here, we got some deadlocks, and as you can see, we have emails here saying, oh, deadlock detected. Okay, enough deadlocks, thank you. Great, so let's go to the email client. And here we have deadlock. So if we click, we see we have the XML of the deadlock graph here in the body of the email. We could also have this information extracted from the MDW database. So we could go here. We have a reporting services instance here pointing to the tables of the management data warehouse. We have blocking and deadlocking, so a custom report on the data collector to deal with the deadlocks. And here we have, if I click here, I can see the list of deadlocks with the timestamps. This is deadlock graph. If I click here, I can download the XDL of the deadlock graph, and it will open the XDL, so the deadlock graph, in a new SQL Server Management Studio window. Okay, here it is. So if you think of what we talked in the first few slides, this is close to a complete monitoring solution. It doesn't have all the value of one of the commercial products, but it has all the nuts and bolts to create your own monitoring solution using the built-in tools found in SQL Server. So you will have to customize this a bit, but it's one of the possibilities. Okay, so great, but this begs the question. How many of you use the data collector? 1, 2. Okay, so this is exactly 2 people more than last time I asked. We probably should use something else. We should use something more simple, and this is why I created XC Smart Target. This is another open source product, open source project, and this is a command line tool, and the goal is to connect to extended events sessions and do some custom action in response to events without writing a single line of code, so DBA style. And so things we could be doing, we could write events to a database table. We could do the same things we did in these examples, so pre-aggregate and filter the events as we did with the logon events. What else? Send emails in response to events. And this is what you can do with the built-in response types we have so far. It's open source, so you can contribute with your own response type, again, here on GitHub. Okay, so I will show you how it works. Let's go again to this virtual machine. Let's close this. We can delete the emails. I will try to do the same, so capture deadlock events, and this time I will do that without using the data collector, but I will use XC Smart Target. So we'll stop this. And this time, I will go with XC Smart Target. Okay, let's open this with code again. This is a command line tool, so what we will have to do is run XC Smart Target and provide as a parameter, as an argument, the path to a JSON file, and the JSON file will contain all the information for dealing with these events. So let's see how this JSON file looks like. Okay, so we need to have something that has this structure. So we need to have the server name to connect to stream the events, the name of the session to attach to, and then a list of responses. So the first response is of the type email response. So we will send an email every time we have a deadlock. SMTP server, username and password for SMTP. Who's the sender? Who's the target recipient? So again, the DBA. Subject, body. We can extract fields and specify them in the parameters like this, so in curly braces. And attachment, this says which field or action save to a temporary file as an attachment and attach to the email. So in this case, XML report. The name to give to the attachment, so deadlock.xdl. And which events are treated by this response, so XML.report events. Then another response type, so we have multiple responses for the same event. We also need to save this information to a target table. And this is what we will do with the table appended response type. So we say here which instance to connect to. This is the name of the database, so XC Smart Target Test, and the table name is deadlocks. Filter for the events we're interested in, so XML deadlock report. And how often it dumps events to the table, so 10 seconds. Okay, columns we want in the table, XML report, that's it. So as you see, we didn't have to write any code. This is all we need to do, configure the tool for capturing these events. Okay, so let's try and run this. Setup creates all we need, so the session and the target database. Then we need to start this. So now, as it says, it's connected to the session on this server, and it's waiting for events. Let's see whether it works or not. We just need to generate some deadlocks. So again, no SharePoint, but we have the script, so don't worry. Deadlocks, deadlocks. And okay, some deadlocks. Let's see the email, and there we have it. We have an email here, and more emails. Okay, enough deadlocks. Yes. Okay, let's have a look at these emails, what we have, the message we asked for. So the deadlock occurred at timestamp. This is one of the fields. And then deadlock.xdl as the attachment. So let's try and open this. Open. And again, Management Studio will start, and we will see the deadlock graph. There it is. So no data collector, very simple, just a configuration file and no code, and we have our results. So we can have this running in the background, either on the server or on an application server. Doesn't need to be on the server. Okay, we stop this. It's pretty cool, isn't it? Okay. Great, so all that glitters is gold. It depends. It depends. Streaming events has a performance impact. First of all, the events have to be captured, and it depends on which event you capture. It could have could be lightweight or not for the server. Also depends on what you do with the event on the client side, on the receiving side. So if you have very complex actions in response to your events, you could start to lag behind on the queue. You could have events accumulating. At some point, SQL Server could decide that if you have too many events in the queue, disconnects the streaming session to protect itself from exploding. Also, as we have discussed in a question, the events are in a queue. So there's a queue server side, which is what you treat with the dispatcher latency. But there's also a queue on the client side. And this queue is impossible to control. So at some point, the events we have in the queue could get stuck if we don't have enough events. So imagine you're capturing deadlocks. Deadlocks do not occur every second. So at some point, they could get stuck because they don't flow to the end of the queue, and there's no new event flowing in the queue to push out the old ones. So what I suggest here is to have some control event that you are sure that happens all the time, not too often, but at least often enough to push out the old events stuck in the queue. What I usually use for this is the checkpoint event. Happens often enough, but not too often. So it's a sort of a way to clear your queue client side. Okay, so this was it. So as we have seen, the streaming API is a lesser known target type. It provides a way to deal with the events, to do actions in response to the events as soon as they occur. If you do that with the API directly, you will have to write some code at some point, either C# or PowerShell. There's also the extended T-SQL corrector if you don't want to write code, but you use the data collector. And if you don't use the data collector, there's an XC Smart Target, which is what I will be using from now on. A few resources for you before we go. I have here links. If you download the slides, you don't need to take pictures of this, so just download the slides. You have links to articles and blog posts on this. You also have the links to the projects on GitHub. So go and have a look and contribute. There's extensive documentation for XC Smart Target. And when in doubt, just drop me a line and we'll respond. Okay, before we go to your questions, I have a question for you. So how many of you will go home and start using XC Smart Target? Fantastic, thank you very much. So questions? Yes, please.
So got two. One is that, like, is there a way to reduce the number of emails? Like, for instance, you have like an email every 10 seconds.
Okay, so what you're asking is there a way to aggregate the email, have one email every 5 minutes or so? There's totally a possibility to do so. You just have to write a particular response type for XC Smart Target or have somebody writing it for you. It's open source, so go ahead and do it.
The second question is that, like, we have multiple SQL servers. What's the best practice for using Smart Target?
Okay, so the question is, where do I place this when I have multiple SQL servers? You could use an application server to centralize this and connect to all your instances. Yes, please?
Is there a setting on the server side if the queue goes up to a certain point, initiate a disconnect from the client to prevent things from, accumulating too much on the server side?
So the question is why it gets disconnected at some point?
So is there a way to actually specify a limit how large that queue grows before disconnecting?
Okay, so the question is there a way to specify how big is the queue? So at which point it gets disconnected? No, there's no way. Yes, please? Sorry, can you say that again? Okay, so all the examples that I have here are linked in the slides, and if you drop me an email, there's also another place where I have all my samples and demos, and you can download. There's also the PowerShell example. More questions? Yes, please.
What's the impact if you created the stream target but you don't have a listener?
Okay, what's the impact if you create the target but you don't have a listener? Okay, so the impact depends on what you do on the receiving side. And having something hooked to the session, so the streaming API connected, that's what has the impact on the session. So if you are not hooking any target to a session, you basically are recording no events, so doing nothing. Yes, another question?
Can you go back on the slide?
Sure. No more questions, so thank you very much.